7B88, line 22, 7B88, luminescent ions, LED, CTE particle transmissions, 5G Wow Seti. There's the alien radio signal, and this one's about visible lights, LED particles, CTE transmissions, luminescent ions, Véronique Jubera, research results for a laser beam alien technology for UFO CORE Engine crystal communications device in line 22 WOW data. Today's July 13th. We're talking about a solid-state nuclear magnetic resonance to magic angle spinning, and keywords from that formula were found in previous videos. Line 22, 7B78, magic angle spinning part 3 formula UFO, and then line 22, 7B87, InGan LED visible light curves. July 1st, my thoughts. The keyword magic angle spinning has several videos and formulas with it. July 1st, keyword from the data formula is solar neutrinos at 465 nm near UV and UV 370 to 410 nm LED, and LED is mentioned as well. From a previous video, Véronique Jubera, assistant, I already did the previous video, sorry. Véronique Jubera, assistant professor, University of Bordeaux. That's her email stuff. She does luminescence, rare earth element, crystallochemistry, and she had something called luminescent powder, visualization and lighting, red phosphors, aim to elaborate new phosphors for plasma display panels. Collaborators with A. Garcia and B. Glorious. Because of their large band gap, borates or phosphates are of interest as host lattices. Now, we talk about lattices in our formulas, right? For the euporium activated YGD-BO3-EU3+, has an application as a red phosphor in plasma display panels. A drawback of this compound is the intense 5D07F1 transition at 593 nm in the orange region of the visible spectrum. By consequence, the emission is not as red as that of Y203-EU3+, also used in PDP, but less efficient, or Y202S-EU3+, employed in cathodoluminescent screens. This is due to the low probability of the 4F electric dipole transitions in this matrix, whose existence requires a lack of a symmetry center at the rare earth site. Another consequence is a relatively long decay time for television application, to favor high probability of electric dipole transitions, and consequently a spectral distribution of the EU3 plus emission is suitable for display a predominant 5D07F2 emission around 620 nm. Light emission aimed to elaborate new phosphors for white diode, Garcia Glorious. Nowadays, several approaches have been exploited to generate white light. As LEDs are monochromatic by nature, generating white light from LEDs can be realized by mixing individual red, green, blue RGB LEDs or to a single InGan based blue 465 nm or near U and UV 370 to 410 nm LED chip coated with one yellow emitting or more. Green, red, and blue, green, red emitting for blue and near UV emitting LEDs respectively. Phosphors that down convert some of the LED chip emission to generate white light by additive synthesis. Structural local probe aimed to study specific luminescence on semiconductor materials. Collaborated with C. Cardinal and M. Truger, Group 5. The rare earth ions luminescence is studied to locate the doping ion in a nanoscale materials. Last results has proved that in mesophorous thin films, it can be localized in the titania wall as well as the surface of the pores. Scintillator. Detection of particles, neutrons, solar neutrinos. Collaborate Garcia aim to optimize the luminescence of CE3+ for neutrons detection. Cerium-doped luminescent materials are used as scintillators for the detection of high-energy particles and G-rays. For this application, the crystals must be very dense in order to present a good absorption of the incident photon. Lithium or boron-containing compounds possess the ability to convert neutrons into secondary ionizing particles. These compounds could provide neutron scintillation detectors. Scintillator materials must exhibit a very fast decay time. The luminescence of cerium is associated with an allowed 5D to 4F electronic transition. With decay times of a few tens of nanoseconds, this ion is the ideal candidate to be used as an activator for this application. It has been recently shown that Li6R1 XCEXBO33R equals YGD. I know it's a bunch of formula stuff there. Crystals have a great potential in neutron imaging. Aim to study the CTE of YB in oxygenized matrices. Fundamental research, Garcia and Glorios. Since a few years, the optical scientific community shows a great interest on the UV invisible CTE because its luminescent properties satisfy the requirements for applications such as the detector of solar neutrinos and scintillators. Because of its 4f13 electronic configuration, all the wiburnum doped compounds have a charge transfer absorption band in the UV range. But the reverse phenomena, also called charge transfer emission, CTE, cannot be observed in all of them. In the 70s, the first CTE of the wiburnum ion was observed by Nakazawa in phosphate lattice and then in oxysulfides compounds. This emission is located in the UV range and presents a decay time of about 100 ns. Recently, other emitting wiburnum doped matrices have been listed. We focus our interest in oxygenized matrices in order to understand the relation between the chemical bonding of the wiburnum ion with the ligand and the optical properties. Here's laser tests on crystals. Collaboration with Celia and CMOH for laser tests. Celia is CELIA, that's the name of the corporation, I guess. To propose fundamental research in order to solve concrete technological problems of nowadays laser systems. It's with collaborated with Garcia, Valquez, Weber, and Vira Fong. In the recent years, many ways of finding new solid-state laser materials have been explored in order to obtain efficient and compact high-energy ultra-fast laser sources. Such sources find applications, for example, in waveguide writing, medical surgery, materials science, and micromachining. Wiburnum doped materials are popular as active laser media because of their absorption spectrum, which is suitable for direct diode pumping, and their large emission bandwidth permitting short pulse generation. The YB ion benefits from a simple energy level structure protecting from excited state absorption. Moreover, because of their small quantum defect and thus low thermal load, YB doped materials offer the potential for high average power short pulse lasers and amplifiers. Up to now, pulses are as short as 47 fs in millijoule pulse energies have been reported from YB doped laser materials. However, several limits, such as thermal, optical effects in crystals that are actually not fully understood up to our knowledge, prevent from simply scaling up to the results to produce pulsed, high average power and high energy sources. So the field of research for new materials and new laser configurations is widely open. We break with the traditional approach of separating fundamental and applied research and propose fundamental research in order to solve specific technological problems of nowadays laser systems. Structural characterization, XRD characterization on powder, XRD pattern refinement on powders. Luminescent on transition metal and rare earth, VUV, UV visible in IR range. Transmission, diffuse, reflectance, remission, and excitation spectra, decay time on the following equipment. Varying carry 5000 from low to room temperature. Spectrofluorometer specs, Jobin Yvonne FL212, UV visible from low temperature, room temperature. Spectrofluorometer specs, Jobin Yvonne VDM 300. Then it did the other measurements. I'm not going to read them all. They're all just different instruments they used. Yeah, you can look it up on their website, okay? Because this is all the different things that they did. Institut de Chimie de la Matière Condensée de Bordeaux, www.icmcb-bordeaux.cnrs.fr. And keyword Google's microscopic imhogenities will be in the next video. Thank you for watching.